Welcome to our PowerPoint on sensation and perception. If you don't have this slide on full screen, go ahead and expand it to full screen. After you expand it, I'd like you just to spend a couple of minutes looking at the slide. So look at the slide and hopefully you're going to see all sorts of parts moving. When you see these spinning around, I'd like you to know that this is not due to the computer program. This is your own mind making this happen. So I'd like you to take a moment and click on the hyperlink that we have below, the APEC Motorcade Stunt. This is a group called the Chasers War on Everything. This is back from 2007. And in this, we're going to see how even trained professionals might have some difficulty with perceiving when there is a threat nearby. If you were able to view the video, you will see that the security personnel failed to detect and interpret events, and they also failed to respond to stimuli appropriately. We will look at some strengths and limitations of human sensation and perception to find clues to what may have gone wrong. We're going to find out that our brain often kind of fills in the blank when we have missing information, and sometimes it will cause us to interpret things incorrectly. Here are some learning objectives for this chapter. By the end of the chapter, you should be able to describe and summarize the capabilities and limitations of human perception, explain the difference between sensation and perception, describe how psychologists measure sensory and difference thresholds, describe the concepts of absolute threshold and difference threshold, discuss the roles attention, motivation, and sensory adaptation play in perception, and describe Weber's law. I've put the key terminology in bold print. Before we get started, I want to go over some definitions. The first two are sensation and perception. Sensation, the awareness resulting from the stimulation of a sense organ. For example, when I touch this table, it is cold and hard, and my sensory receptors on my fingertips are activated. They are activated, and then a signal will be sent from these fingertips up to my brain. Perception is the organization and interpretation of sensation, the input from sense organs. So basically, when that signal is sent from my fingertips up into my brain, that is where perception occurs. The perception is my interpretation of what that sensation means. So to me, it's like I feel this cold table and I understand, oh, that's the table. I have a history with tables. I understand that this is a table. I know there's a table there. Sensation and perception work together to take in information from the senses, add that information to what we already know, and make judgments to choose appropriate response or behavior. So, transduction, the conversion of stimuli detected by receptor cells to electrical impulses that are then transported to the brain. Transduction is a very complicated chemical process. Basically, all you need to know about that is that when I touch the surface and I have sensation, my fingertips sensory receptors are activated, and then after they are activated, a chemical process occurs that changes and converts the stimuli into an electrical impulse. And it's a really complicated thing, but all you need to know is the name of it and what it is. Here is another note about transduction. The conversion of stimuli detected by receptor cells to electrical impulses that are then transported to the brain. So once again, when I touch the table, the sensory receptors in my fingertips are activated. At that point, transduction occurs to translate that chemical energy to electrical impulses that are then sent up to my brain where perception can occur. All of your senses use transduction, and stimulus in this case is energy that produces a response in a sense organ. We'll use stimulus a little bit differently in our learning chapter. So how many senses do you have? Take a minute and try to name as many senses as you can. In grade school, we learned that we have 5 basic senses. However, in reality, we have a lot more senses than just 5. And here are our main senses. We have vision, hearing, which is also audition, smell, which is also called olfaction, taste, gustation, touch, somatosensation, balance, vestibular sense, movement, proprioception and kinesthesia, pain, nocioception, and temperature, thermoreception. Sensory thresholds in humans. Interestingly, your eyes can see a candle from 30 miles away. Now, if you've ever driven down the road and looked up at the mountains and saw a light up on the mountain, it makes sense that you might be able to see some light from a long distance on a clear night. There have been estimates that we can see 300,000 to 7 million different colors, depending on what research papers you're looking at. Your ears can hear a clock tick from 20 feet away in a quiet room. And if any of you have ever been in a room taking a test where the clock is ticking, ooh, it's just a horrible sensation to hear that. Your tongue can taste 1 teaspoon of sugar dissolved in 2 gallons of water. And your nose can smell 1 drop of perfume in a 3-room apartment. And our skin is exceptionally sensitive, and we can feel a gentle breeze blowing across our skin. So humans have some really amazing senses. Let's take a look at some other critters. Dogs, bats, whales, and some rodents have better hearing and smell than humans. Birds can see with ultraviolet light and can sense the pull of the magnetic field. That is how they navigate. We believe they use the magnetic field to be able to migrate. Cats are extremely sensitive to touch, and their whiskers help them to see in the dark. The platypus is an amazing animal with an electromagnetic sensor in its bill. I've linked a video of a platypus, so after this slide is over, then I would like you to go ahead and click on that link and take a look at the platypus. All of these animals, including humans, have evolved with species-specific evolutionary adaptations. For example, birds have extremely good vision because they use that vision to help them to get their prey. Bats, dogs, and these other animals need better senses of hearing and smell. Humans, we are very visual creatures. We do not have the kind of acute vision that birds have, but we have pretty good vision. And one of our main senses that we use to interpret the world around us is our vision. Adaptation is important to help organisms to attend to what matters. That means to pay attention to what matters and be able to know when something around them is important, and discount irrelevant stimuli. So we need to be able to throw out the sounds and things around us that are not important and be able to pay attention to the stimuli that's coming in that is important for our survival. I hope you enjoyed that video of the platypus. In case you didn't know, the platypus is the only egg-laying mammal that we have on the planet. And in addition, it is the only venomous mammal, as the male platypus has these little barbs on his hind feet that can inject venom. So this slide is going to show us what birds see. Because birds can see ultraviolet light, but humans cannot, what looks to us like a plain black bird looks much different to a bird. So if you look at these pictures, what you're seeing is the black bird with just a little yellow on him, a yellow beak, and a little splash of white, where the bird is seeing lavender, green, bright blue, yellow, purple, all these different colors. It's pretty cool. Now we're going to dive into one of our more complicated topics, absolute threshold, the smallest intensity of a stimulus that allows an organism to just barely detect it 50% of the time. That might sound a little complicated, so hopefully I can make it a little more simple for you. An example of absolute threshold is getting a hearing test. If any of you have ever had a hearing test, you'll know that you'll sit in a booth with headphones on. They're going to ask you to like raise your finger or your hand every time you hear a sound. What happens is they want to find your absolute threshold. They want to know what is the smallest sensation that you can detect. So what is the faintest sound that you'll be able to detect accurately 50% of the time? So when you're sitting there in that booth with that hearing test, sometimes you think you hear it, so you raise your hand, you may or may not be correct. It starts off with loud sounds that are easy to hear, and then it gets softer and softer until you get to where you're just not really sure if you can hear it. When you correctly indicate 50% of the time that you can hear the sound, that is where your absolute threshold is. So that is the smallest intensity of a stimulus that allows an organism to just barely detect it 50% of the time. So hopefully that makes more sense now. The type of test that is used is called signal detection analysis. It's a technique used to determine the ability of the perceiver to separate true signal from background noise. So background noise is just being able to pick out the appropriate sound that you're supposed to identify and ignore the background sounds. Noise is the term used for background stimulation that interferes with the perception of other stimuli. That is unwanted stimuli that interferes with other senses. Our next concept is the difference threshold, which is also called the just noticeable difference. That is a change in stimulus that can just barely be detected. Ernst Weber, 1795 to 1878, I don't know what all those other zeros are for, discovered that the ability to detect differences depends on the size of the difference in relation to the absolute size of the stimulus. The just noticeable difference of a stimulus is a constant proportion of the original intensity of a stimulus. What? What the heck did I just say? Well, I will try to clarify it with a few more examples. I'm going to start with an example that is not on our screen. So the just noticeable difference is the ability to detect a change in stimulus. For example, if I'm listening to the radio, how many more decibels do I have to add to know that I have changed it to a louder volume? So if I just turn it like one click, 1 decibel, can I tell that it's louder than the other one? If I have the two side by side, I listen to the two sounds, will I be able to determine that one is louder than the other? I may have to go like a few more decibels before I can tell the difference. Another example would be light. If I have a light that is very, very bright, and another light that is just a tiny bit less bright and they're next to each other, I probably am not going to be able to tell the difference. However, if I have one that is bright and one that is fairly dim, I will be able to tell the difference between those two lights. So the example on the screen is 1 cup of coffee with 1 teaspoon of sugar. So when we have a cup of coffee and then we add a teaspoon of sugar, we can definitely taste that there is 1 teaspoon of sugar. We can taste that sugar in that cup of coffee. If we add a second teaspoon, we may still be able to tell that it is sweeter than before. It makes a noticeable difference in taste from having no sugar to 1 teaspoon of sugar, and then we can tell when we add that second teaspoon of sugar. We can detect a taste difference in all 3 of those. However, if we have that cup of coffee and we now add 5 teaspoons of sugar, we have 5 teaspoons of sugar in it. Then we add another teaspoon of sugar. We probably are not going to be able to tell the difference between the 5 teaspoons of sugar and the 6 teaspoons of sugar. We will not be able to detect that difference. So how much would a stimulus have to change for me to notice a difference? In other words, what would it take for me to have a just noticeable difference in my stimuli? How much salt would I have to put on a potato chip to taste the difference? How much would I have to turn the volume up or down to hear a difference in the sound? How much would the brightness of a light have to change before I could tell a difference in brightness? These are some examples of just noticeable difference. So here are some examples of proportion. If you look at the bottom of the slide, the just noticeable difference of a stimulus is a constant proportion of the original intensity of a stimulus. So if we have a candy bar that was $1 and now we have to pay $3, that $2 seems like a very big difference. If we have a stereo that we want to purchase and it was priced at $262 and now we have to pay $264, it's really no big deal to fork over that extra $2. That $2 seems like a very little difference. That difference is based on where we started from. If we're starting out with $1 and have to pay $3, that's a huge difference. If we're starting out with 262, we have just a small difference. It's a very small proportion of the original intensity. That brings us to Weber's law. The just noticeable difference of a stimulus is a constant proportion of the original intensity of a stimulus. In other words, you have to have a certain amount of change before you can detect that the stimulus has changed. For example, you have to have 1 ounce of weight increase to notice a difference in something weighing 50 ounces. You must have a 10 ounce of weight increase to notice a difference in something weighing 500 ounces. So in other words, in order to detect the change, you have to have a certain proportion of change occur. You're not going to be responsible for knowing the ratios or any of that. Just know that Weber's law is the law that is used to tell us that the just noticeable difference of a stimulus is constant proportion of the original intensity of a stimulus. Our next topic is sensory adaptation, turning down our responses. Adaptation, adjustment in sensory capacity after prolonged exposure to unchanging stimuli. A decline in sensitivity to sensory stimuli. So basically, it is an inability of the sensory nerve receptors to fire off messages to the brain indefinitely. So I'm going to give you some examples of sensory adaptation. First of all, have you ever been somewhere or to somebody's house that lives next to an airport where the planes are flying over all day and you go visit and you're like, oh my gosh, how can you even stand having these planes fly over every day? And the people are just like, oh, well, we're used to it. We don't even hear them anymore. Or somebody that lives next to a railroad track, they become they have sensory adaptation when it comes to the trains going by. You may be sitting there talking, a train goes by, and you're like, oh my gosh. And they're like, oh no, I'm used to it. I don't even hear those trains anymore. Those are examples of sensory adaptation. Some other examples are, well, you're probably sitting in a chair or laying on your bed listening to this PowerPoint, I hope. So as you're laying there, do you notice the skin on your clothing? If you stop and think about it for a minute, oh, I can feel my shirt touching my arm. I can feel my bottom sitting on the chair or sitting on the bed. You can feel those now that you're paying attention. You're using attention and you are focusing on those things. However, prior to that, you did not pay any attention to your clothes touching your skin or the seat you're sitting on. Those sensations were put to the side, they were unimportant. So your body, your sensory system adapted and decided to respond only to those things that are important. Next, let's talk about subliminal stimuli. Subliminal stimuli is stimuli that occurs just below the absolute threshold. So remember, our absolute threshold is when we can detect a stimulus accurately 50% of the time. So a subliminal stimuli would be below that threshold. So research shows that this type of stimuli has little effect on behavior. There have been some studies that show that for the short term, you may be affected by subliminal stimuli. For example, there have been studies that a person has been watching a screen and then below their perceptual level, they would flash words like thirst, drinks, and then when they're done with watching the video that they were watching or the PowerPoint or whatever it was, then they would be asked to rate how thirsty they were. People who were exposed to the words would say they were more thirsty than ones who were not exposed, or they had words that were just neutral, like flower, bug, something like that. So the effects of subliminal stimuli are usually very short term. It's not something that's going to last for a long time. It's pretty immediate effect. Some studies have shown that product placement, on the other hand, can have a larger effect on increasing snacking behavior. For example, you're watching a TV show, the main character's drinking a Dr. Pepper and chowing on some Doritos, and then it's like, oh my gosh, I want some Doritos and I want a Dr. Pepper. That kind of product placement seems to work better than any type of subliminal stimuli. It has more of a lasting effect. You may pause your movie and go get some chips. So we've been talking about our senses and the sensory portion of things. And now we're going to focus a little bit more on perception and types of processing. So when we're talking about perception, we have basically two types of processing: bottom-up processing and top-down processing. Bottom-up processing is perceptions built on sensory input, built on individual components of stimuli. Top-down processing, perceptions influenced from experiences, available knowledge, thoughts, expectations, and motivations. In other words, the bottom-up is coming from our sensory organs up into the brain, where the top-down processing is coming from our experiences kind of outward. They work together to give us a better interpretation of the world around us. So an example of bottom-up processing, say I'm staying at my brother's house, it's dark, I get up to go to the bathroom. I'm heading into the bathroom. All of a sudden, something furry is rubbing against my leg. I jump up. I'm like, oh my gosh, what is that? So that's my bottom up processing. Something rubbed across my leg, stimulating my senses giving me sensory input. And for a moment, I'm like, what in the world is that? Then I start having some top down processing. It's like, oh, wait a minute. My brother has a new fluffy cat. So it must be the fluffy cat that hit my leg. And so that's the top down portion. So the bottom up was like stimulated by my sensory input, where the top down is based on my perceptions, my experiences, and my available knowledge. So those perceptions are built on the knowledge that I have and the thoughts. So they work together to give us a better interpretation of the world around us. So on this slide, I've put together some key takeaways. Sensation, process of receiving information from the environment. Transduction, conversion of stimuli detected by receptor cells into electrical impulses, and I left off the word impulses. Different species have their own adapted sensory strength and limitations. Perception, process of interpreting and organizing incoming information in order to understand it and react accordingly. Sensation and perception work together. Absolute threshold, the smallest intensity of a stimulus that allows us to just barely detect it 50% of the time. Key takeaways continued. Signal detection analysis used to differentiate stimulus from background. Weber's law, the just noticeable difference increases in proportion to the total intensity of the stimulus. Difference threshold, just noticeable difference. The ability to detect the smallest change in stimulus about 50% of the time. Stimulus can have minor influence on behavior even when presented below absolute threshold. So that's basically referring to subliminal stimulus. Let's move on to talking about vision. On this slide, I put 3 different links that would be useful for you to watch. Please watch the first 2 before moving on to the next slides. The first one is called prosopagnosia, sensation without perception. The second one is called color perception, how do we see color? Please go ahead and watch these 2 videos before moving on to the next slide. The third link that I have provided is a 45-minute episode of Brain Games about perception. You may want to watch the first 10-15 minutes of this video before moving on. Otherwise, you might want to set 45 minutes aside and take a look at this video. It's really useful for helping understand sensation and perception.